All right, so again, it's the tilt of the moon's orbit around the Earth that that is the reason that there's not a solar eclipse or a lunar eclipse each month. Um, all right, so it's actually, I think this is more confusing than anything else, um, to try to explain this picture, but at any rate. It's just trying to show you that the eclipses don't happen all the time. They're pretty rare. Okay, so for example, there's the one in 2017. There's the one in 2024. And remember, for us in South Carolina, um, this one in 2024 was only a partial eclipse. All right, and you can see there's nothing um, coming across the United States for uh, in the foreseeable future. So you'll have to go somewhere else on the planet. Um, I mean, there's one going over the southern part of Africa in 2030, and looks like it's going to go across Australia. Oh, 2028 looks like a good one across Australia too. And 2023, maybe in Alaska, northern Alaska, in March. I don't know, it's still pretty cold in March. Anyhow, just to let you can see, some of the past eclipses, and notice most of these lines is you know is over ocean, right? Because that's what two thirds of the planet is ocean. Let's see, phases and cycle appendix. Looking down at the moon from above, the moon travels counterclockwise. Okay, well, I think we talked about that. We did the phases. They're just talking. This is just the phases of the moon. That's all. They're just kind of walking you through the phases of the moon. Oh, okay. Well, I guess that is the end of the chapter. All right. So what I'm going to do is let me do some examples of. I think I'm going to do a couple of examples. All right, just give me a minute here. All right. So actually, let me get my calculator. I'm just to let you know, I do not like this calculator at all. Uh, I'm using it. I know I'm using it, and you might say, "Well, why?" The only reason I'm using this one is it's the easiest one that I have when it comes to this computer that I'm making this video on. Okay, so that it just makes life simpler, I should say. All right, let me start by saying I think I mentioned this before. We have this. Oh, I don't like that at all. Hold on, let me change this to something better, like a marker. I don't know. Let's see. What is that? Oh, that does not. That's crazy looking. Sorry. Um, Here, let me pause. All right, let's try this again. Something a little bit more reasonable. We know that in 1 degree. All right. That was hoping that would be wider. Try this. 1 degree is the equivalent of. All right, so 1 degree is what we call, just imagine a degree, right? So this is just some angle where this is 1 degree. All right, so that's a little circle right there. So that 1 degree can be written this way: 1 degree. All right. So it turns out that 1 degree is actually a huge portion of the night of the sky in general. Like if you looked at the full moon, or don't ever do this, if you looked at the sun is about half a degree. So what we do in astronomy is we break up the degrees into smaller things. So it turns out that 1 degree is the equivalent of what we call 60 arc minutes. All right, so 60 arc minutes. And there's another way to write 60 arc minutes, which you'll see me write this both ways. And so it looks like this. Not just me, this is just a universal. So you'll see this word, or you'll see this as arc minute, or you'll see like a single hash mark. So 60 arc minutes is the equivalent of 1 degree. So that's a conversion, right? So that, that's a small. Imagine you had 1 degree and you broke it up into 60 equal parts, right? And so, for example, the full moon is 30 arc minutes in size, or half a degree. It means the same thing, right? So another way to do this is to go even smaller than a degree. So one smaller than an arc minute. So 1 arc minute, right? 1 arc minute. So I'll write it this way, and also write it 1 arc minute. Okay, so a single hash tag means 1 arc minute is the equivalent of, you probably guessed it, 60 what are called arc seconds. All right, arc seconds. All right, and so the way that you write that one is 60 with 2 hash marks. All right, so the 2 hash marks mean arc second. The single hash mark means arc minute. All right, so let's do some conversions. All right, because that's the kind of thing that you're going to see. So once you know that 1 degree is 60 arc minutes and 1 arc minute is 60 arc seconds, it is really easy to do. All right, so we'll do some conversions. So notice over here I've written the conversions. This says 1 degree. The little circle there means degree. 1 degree is 60. 1 hash mark is arc minutes. So 1 degree is 60 arc minutes, and 1 arc minute is 60 arc seconds. So an arc second, by the way, is a really small it's a really small angle, right? An extremely small angle. All right, so for example, if I had, let's say I had, I'm going to do two different conversions here. Let's say I had 29.7 arc minutes. Okay, so that let's say that's my angle, all right? So I'm going to call that, very traditionally we call angles Greek letters in the sciences. All right, so that angle is called, that's theta. Theta is the angle. You can use alpha, you can use beta, or things like that. All right, but anyhow, if theta was 29.7 arc minutes, what is theta? So theta is equal to question mark in degrees. How many degrees is it? And then, of course, since we know what it is in arc minutes, how many? So question mark, how many arc seconds is that? All right. So all we do is we use these conversions. All right. So here, if you've not done any conversions, you do them the same way in all the sciences. You just have to know the conversion factors, which I have right here. Okay. So that's what this stuff is all about. All right. So try to get that in there. All right. All right. So here we go. All right. So I'm going to write it out. All right. So theta. So I'll do the degrees first. All right. So it's 29.7 arc minutes. But then what I do is I say, all right, I'm going to draw. This is just a parentheses. I'm going to draw some fraction. All right. So I'm either going to pick. I'm going to pick this conversion or this conversion. All right. Well, since I'm going to degrees and I'm already in arc minutes, I'm going to choose the top one, which says that there are 60 arc minutes in 1 degree. All right, so you have to, and I'll just close parentheses for completeness. See, this right here has to cancel this. All right, they must cancel each other. And then so the answer, so once you do the mathematical calculation of just what's 29.7 divided by 60, all right, so here, let me get my calculator. Where's the mouse? Oh, there it is. So here's the calculator. Again, that's the only reason I use this is because it appears nicely on this. So 29.7 divided by 60. All right, so that's going to be how many degrees it is. All right, so 0.495. All right, and we'll talk later about doing rounding to a certain significant figure and so on and so forth. But right now, I'm just going to put 0.49. So 0.495 degrees. So this many arc minutes is this many degrees. All right. So now let's do the conversion, and we'll convert it to so the same angle, right? So remember, this is the same. This angle right here in arc minutes is the same as 0.495 degrees. All right. So anyhow, 29.7 arc minutes is how many? So all I'm doing is so obviously I'm going to use this bottom conversion now. So see, 1 degree is 60 arc seconds. 1 degree, sorry, I said that wrong. 1 arc minute. All right, so I'm using this bottom one. 1 arc minute is 60 arc seconds. So 1 arc minute is 60 arc seconds. All right, so this cancels this, right? The units cancel, and so you just take 29.7 and you multiply it by 60. All right, I guess I should close the parentheses just to have it complete. All right, so here, let's get that to appear. All right, so let's clear that. All right, so we have 29.7 times 60. All right, so remember, we're converting it into arc seconds. All right, so it turns out that this is 1,700, and I didn't see what the other, and 82, 1,782 arc seconds. So you can write it like that, or you can write it like this. Either way is perfectly fine. 1,782 arc seconds. All right, arc seconds. This is supposed to be an R. Sorry, it doesn't look like an R. Arc seconds. All right, so that's some conversions. All right, let's do the angle of the sun. All right, so here's the equation. By the way, this will be given to you on the equation sheet. The angle of the noonday sun. Okay, so noon is when the sun is the highest in the sky. The angle depends on your latitude. This is the angle with respect to the horizon. All right, so on the first day of summer, the angle is 90 degrees minus whatever your latitude is, plus 23.5 degrees. And then on the winter, it's 90 degrees minus your latitude. It's always 90 degrees minus your latitude. For the winter, it's going to be minus 23.5 degrees. And then for the equinoxes, for fall and spring, it's 90 minus the latitude. All right, so here, let's do a quick example. So here, let me pause this. All right, so I've just worked it all out for 45 degrees, or 45 degrees, if that's your latitude, on the first day of spring or the first day of fall, it's going to be 90 minus 45. That's of course 45. So the sun is going at noon on that day. It's at 45 degrees. On the first day of the summer, at an angle, the angle would be 68.5 degrees. All right, and you just follow these formulas. In the first day of winter, it would be 21.5 degrees. Quite a difference.